When you try to picture a drug addict, a very specific image probably comes to mind. Our culture has trained us to imagine a weak-willed hedonist, a violent criminal, or a tragic victim suffering from a terminal brain disease. But the statistical reality of drug use contradicts that image entirely. The vast majority of human beings will experiment with highly addictive, mood-altering substances during their lifetimes. This diagram illustrates a surprising reality. Out of all the people who try the hardest, most stigmatized drugs like heroin or crack cocaine, only 10 to 20% ever actually develop a severe addiction. To explain why most people can walk away while a few get trapped, society constructed the idea of an addictive personality. We assumed certain people were simply born selfish or out of control. But psychological studies tracking individuals from childhood into adulthood reveal no such universal character trait exists. Instead, the data points to a very different diagnosis. Addiction is a neurodevelopmental learning disorder. It belongs in the exact same category as ADHD, dyslexia, or autism, conditions that result from differences in how the brain wires itself over time in response to its environment. By treating this wiring difference as either a moral failure or a chronic physical illness, our justice and medical systems have spent a century fighting the wrong enemy. The biological groundwork for addiction is laid long before anyone takes their first drink or drug. Studies following children from birth show that risk is highly concentrated among temperamental outliers, kids who are either extremely bold and impulsive or highly anxious and neurodivergent. Science journalist Maia Szalavitz, who was diagnosed with ADHD and Asperger's traits as a child, explains this vulnerability through what researchers call the intense world theory. She was also hyperlexic, meaning she taught herself to read before age 3 without formal instruction. To a child wired this way, ordinary life is physically overwhelming. Fluorescent lights sting like strobe lights, and background chatter becomes a deafening roar. Social expectations dissolve into a chaotic, unreadable mess. To survive this daily barrage, these children develop specialized coping mechanisms. They might rock back and forth, fixate on highly specific subjects, or withdraw entirely just to find a predictable pattern in a terrifying environment. These early extremes in temperament act as the raw kindling for addiction. They dictate how a vulnerable brain learns to soothe itself when the world becomes too loud. As these children enter adolescence, their biology enters a sensitive period. This is a critical developmental window where the brain is highly receptive, actively expecting specific social and emotional experiences to finalize its adult wiring. If an overwhelmed teenager introduces alcohol or opioids during this sensitive window, the substance instantly dampens the internal noise, filtering out constant sensory and social pressure. Taking that drug is rarely about chasing pleasure. For a nervous system that has been on high alert since childhood, that first hit is a profound, deeply felt arrival at safety. Because this intense relief arrives during a sensitive period, the developing brain takes notice. It prioritizes this highly effective chemical shortcut over the slow, organic work of learning to manage emotions. The substance provides such a reliable shield during this critical window that the maturing brain files it away as a necessary survival tool, like eating or sleeping. By early adulthood, what started as a temporary biological shield hardens into a permanent cage. This happens through a neurological process called overlearning. When a behavior is repeated enough, brain plasticity, its physical ability to change and adapt, drops, making the habit resistant to change. You can see this same lock-in effect in technology, a concept called path dependence. Take the QWERTY keyboard, an arbitrary design choice made in the 1870s to prevent mechanical keys from jamming. Even though better layouts exist today, the system is so heavily adopted it's nearly impossible to alter. This diagram shows path dependence in human neurology. The drug-seeking route is reinforced thousands of times, becoming a biological superhighway. Bypassing smaller, healthier side paths, this overlearned loop physically overrides the prefrontal cortex, the area responsible for logic and self-control. The individual continues the behavior, even when it results in arrest, poverty, or severe physical harm. The addicted brain is not broken. It is doing exactly what evolution designed it to do. It just learned a maladaptive survival strategy far too well. If we accept that addiction is a learning disorder, our society's reliance on the criminal justice system to fix it is entirely backward. When humans are threatened with violence or prison, the biology of fear takes over. Threat literally shunts energy away from the prefrontal cortex and down into the primal reactive centers of the brain. Fear physically disables the exact neural hardware required to learn new behaviors. Yet for decades, drug policies have relied on moral panic and racial stigma to punish users, ignoring the developmental roots of why people use substances in the first place. Focusing entirely on the chemical rather than the human produces fatal logic. During Prohibition, the government ordered manufacturers to add lethal poisons to industrial alcohol to deter bootleggers. Thousands of people died simply because the law tried to punish a biological compulsion out of existence. You cannot traumatize a learning disorder out of someone, and a judge cannot arrest a biological coping mechanism. But looking at addiction through the lens of learning reveals a highly optimistic reality. It is not a permanent, progressive death sentence. This line chart tracks addiction rates over a human lifespan. Notice the massive spike in the late teens and early 20s. Now look at what happens next. The rate drastically plummets. The vast majority of these addictions naturally end by age 30. This drop-off coincides precisely with biology. In the mid to late 20s, the frontal lobes finally finish maturing. Individuals naturally gain executive function, the mental skills required for self-control and future planning, allowing them to simply outgrow the disorder. For those who need help accelerating this unlearning process, the required tools are social support, deep, genuine empathy, and positive incentives. These are the optimal conditions the brain needs to safely rewire its neural pathways. To actually solve the addiction crisis, we have to stop treating people as defective criminals. Instead, we have to help them unlearn their survival strategies in a world they no longer need to hide from.